Hello and welcome to section 6.6. There are 3 videos for this section. This is video 1 of 3. Section 6.6, we look at the law of cosines. Law of cosines. In section 6.5, we looked at law of sine. And we needed very specific pieces of information. What do we need? We need an angle and the side opposite of that angle, and then we just need one other side or angle. That's fine if that's the information we're given. But if given a triangle with 2 sides and the angle between them, so not the angle opposite, but the angle between them, or the lengths of all 3 sides we cannot use law of sines. Again, law of sines is very specific what information we need. If we're given 2 sides and an angle between them, or if we're just given 3 sides, law of sines is useless to us. But that's where law of cosines comes in. We have the following. This is absolutely a cheat sheet item. You'll want to know this. Again, we're going to do so many examples of this, you'll probably know the formula by the end of the semester. But for now, especially early on here, reference for your homework, exam 1, make sure you have this on your cheat sheet. So we have the following. In triangle ABC, the law of cosines says that a squared, so the length of the side A, if we square that value, it's equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. It's similar for b and c. So I could say b squared is equal to a squared plus c squared minus 2ac cosine of b, and likewise for c. But do I really need b or c? And the answer is no, not really. Because it's arbitrary what angle or what sides you're calling a, b, or c. So just use the information you have and then call the unknown pieces a. And then you can get away with not having to memorize all these other formulas. And the truth is, they're not that difficult to remember anyways. And why is that? Well, whatever side we're trying to find, or if we're given it and say we're trying to find an angle, these guys match up. So if we're using angle A, cosine of A, it matches up with what's on the other side of the equal sign. And then we're just squaring both sides, and whatever values these are, B goes here, C goes here. Now, one thing I want to point out is that this last piece is all one piece. It's not like you can say, oh, this is a number and that's a number, so I just need to square these and add them and subtract this. So for example, sometimes I'll see like a squared is whatever, 9 plus 8 minus, once we get done doing this, maybe it's, I don't know, 6 cosine, whatever, 120 degrees. I'm making this up, obviously, as I go. You can't say that, oh, okay, I can just do 9 plus 8 is 17, minus 6 is 11. So this is just 11 cosine of 120. That is not equal to that. This 6 is multiplied by that, so it's attached to it. You can't just look at these three numbers and then subtract them or add them and come up with a value. And I'm telling you this because I'm going to see it on the first exam. I'll see it on the second exam. Well, not the first exam, but the second, the third, and the final. Please, if this is something you're inclined to feel like doing, think back to this video where I'm pleading with you, don't do that. It's not order of operations. What's order of operations? You have to multiply first, then you add or subtract. So again, just be careful you don't do something like that. I don't want to mark your problems wrong because you made a goofy little arithmetic error. So this is our formula. Again, we could interchange A, B's, and C's, but it is essentially the same formula. So let's look at where we can use this. So let's say we have the following example. Sides of a triangle are A equals 5, B equals 8, C is equal to 12. And we want to find the angles. So if I was to sort of draw a picture of what's going on here, again, it's arbitrary where I put A, B, or C. So A is 5 over here, length of B is opposite angle B, length of C is opposite angle C. Does this triangle make sense? Yeah, 8 and 5 is 13, which is longer than the shorter side. So now, let's just figure out A. It's alphabetical, so you could figure out whichever one you want. So using the law of cosines, says I'm given three sides. I'm not given any angles, so I can't use law of sines here. But if I want to figure out what is angle A, I can use law of cosines, and it tells me what? That the length of A, the side A squared, so 5 squared, is equal to 8 squared plus 12 squared minus 2 times B, which is 8, times C, which is 12, times cosine of angle A. That's our unknown. We're trying to find that angle. So this is what? This gives me 25 is 64 plus 144 minus, well, 2 times 8 times 12 gives me 192. So minus 192 times cosine of A. Again, these guys are connected. So don't add these two and then subtract 192. If I do my algebra, so if I move this piece over, subtract the 25, and then divide by 1. So let's do that first. So let's bring this one over here. So I get 192 cosine of A, that way it's positive, is equal to what? 64 plus 144 minus, because I'm subtracting 25 from both sides. So now to get cosine A by itself, what do I have to do? I have to divide by 192. So you can see if we would have just subtracted over there, we have no chance of getting this thing right. So that tells me what? Cosine of A is equal to roughly 0.953, which means that angle A is about 18 degrees. So using law of cosines, we can figure out one of these angles. Now we just have to do the same thing for these other ones. So I'm going to go ahead and erase this. If you're still catching up on the writing, if you're trying to go back and see the algebra and the math, go ahead and pause it. Otherwise, I'm going to erase this and we'll figure out B and C. All right, so for angle B, again, we're going to use law of cosines, and it's just we're going to move the letters around, but it's still essentially the same formula. So we have what? We have b squared is a squared plus c squared minus 2ac, because whatever's on this side goes next to the 2. And then this one is cosine of b. It's the same formula. Essentially all we did is wherever there was a's and b's, we switched them. So this was a before, now it's b. This was b before, now it's a. And then a's and b's over there, we switched. But it's the same formula. So now we have what? 8 squared is equal to 5 squared plus 12 squared minus 2 times 5 times 12 times cosine of b, the value we're trying to figure out, angle b. Again, if we do the math at some point here, the algebra, we move this over, we subtract the 8 squared, then we divide. 2 times 5 is 10 times 12 is 120. So at some point we should get that cosine of b would be equal to, so 8 squared. So if we bring this over and bring the 8 over, we get 25 plus 144 minus 64 all over 120. So cosine of b is approximately 0.875. So that means that that means that b, angle b, is approximately 29 degrees. So, you know what you're saying to yourself. It's like, well, wait a minute. Once I got to this point, I had a side and an angle and a side, so couldn't I have just used law of sines there? The answer is yes, you could have, but it would have given us 2 possibilities for angle B. And that was that case where then do we have to solve both of them? With law of cosines, we don't have to do that. So it would just give us angle B is equal to 29 degrees. And then lastly, angle C. So same formula, we're just switching stuff around again, the A's and the C's. So C squared is A squared plus B squared minus 2AB cosine of C. So if we plug in those values, we get 12 squared is 5 squared plus 8 squared minus 2 times 5 times 8 cosine of C. Again, if we do all the algebra, move the pieces around, so add this over here, subtract that there, what do we get? We get cosine of C is 25 plus 64 minus 144 all over, so 2 times 5 is 10 times 8 is 80. So when you calculate those values, do inverse cosine function, it gives us that angle C is approximately 133 degrees. So now I know what you're saying. Well, wait a minute. If I have this as 18 and that's 29, can't I just do 180 minus those values? And there I will tell you, yes, you can. So you wouldn't have to use cosine of C for a third time. If you have these two, you can just subtract them. Now, that being said, if either that value is wrong or the 18 degrees is wrong, if you subtract them, you're going to get the wrong value for C. So that way, at least at this point, then you could go back and check your work. If you add these up, do they equal 180? Yes, they do. So you know you would be okay at that point. So that's the end of video 1. Sort of an introduction to law of cosines, what's the formula for it, and then how do we apply it. So I'll see you guys in video 2 for section 6.6.